All right, we're going to go ahead and take a look at problem 5 on test in the year 2018. So this was our one variable descriptive data. So here we had 2 quantitative graphs of histograms, high school A, high school B, and then they were the teaching years. And so they also stated here that the teacher years recorded as an integer, that's a whole number, and that they also specifically state, which this is what an integer does, a histogram does, is that the left value is the first one included in that bar. So 1, and then, so for example, over here on high school A, 1, 2, and 3 would be the years included in this first bar. 4 would start, teachers that worked in 4 years would start in this second bar, okay? And so that's typically how that's done. So the first question is so they did have the same mean of 8.2. High school A had a slightly little less, 200 teachers. High school B had 221 teachers. Now, they asked you if they said a median for one of these is 6, a median for one of these high schools is 7, which one's which, and justify your answer. So, see, and it says there, justify your answer. Okay, so that's critical to getting this correct, getting your credit here. So there were 2 different ways that you can get credit. So first component you had to get correct was identify that high school B had a median of 6. High school A had a median of 7. If you did not state that, you automatically got 0 credit for this component. The second way was to justify it one of 2 ways, either by the definition of the median and stating how you got that value, or using the idea of skewness and distance of the median from the mean. So those are the 2 ways. I did the first method where I stated that the median is the 50th percentile. See, the median is the 50th percentile. So identified the bar that 50th percentile piece of data was found in. So for a sample size of 200, that 50th piece of data or 50th percentile was 100. So then based on how much information is in each of these bars, that puts the 50th percentile, the 100th-ish piece of data right here in the third bar. Therefore, that one must be 7 rather than 6. Because our high school B had a sample size of 221, then we were using the median location of the 110th-ish piece of data. So therefore, we counted that 79 were in here, 34 were in here, which takes you up to 113. So here we have the 110th-ish piece of data in this second bar. That then indicates that it is 4, 5, or 6 years. So definitely not the 7. All right, so to get full credit, here's how the grading guidelines read. You state that the median is 6 for high school B and the median is 7 for high school A. Provide that reasonable explanation on how the decision was made by discussing the definition of median right here and applying that definition to the histograms. Here's your other one, of course, stating the correct high school A and B relationship. States that high school B showed more skew. Oh, I didn't describe that. So more skew. So that's the second way that you could get this answer. So you could say high school B was more skewed to the right than high school A. And so when you have more skew, then that's making that distance between the mean and the median greater away. Remember that mean is pulled in that direction of the skew. So skewed right, that mean is pulled up. And so that would be it's pulled higher for more skew, making the median farther away at 6. All right, so then that is the second way that you could get essentially correct, provides that explanation based on the more skewness of B and the larger separation between the mean and the median. All right, so you would get partially correct if you identified the correct high school median value, but you did a poor job of describing the reason why that you came to that conclusion. Okay, so you were kind of hem-hawing around or didn't really like exactly state this is statistical justification and so on and so forth. So there you go. That's how you would get partial correct. And then if you, of course, didn't get 6 and 7 in the correct place, you got incomplete. All right, the second component, question part B, says that they add 18 teachers to high school A. So high school A had 200 teachers with a mean of 8.2 years. Then they added 18 teachers with a mean of 2.5. So a much lower mean, of course. So what's that going to do? Specifically, it said the mean. What is the mean then for all 218 teachers? So you had to do this weighted averaging. And so here's how the math for that worked out. You had this 200 teachers times that 8.2 gave you a sum of those teachers' years as 1640. And then you had this 18 times 2.5 gave a sum for those teachers' years of 45. You added those together to get a new total sum, which when you divided by 2.8 or 218 was 7.73. So the way that you got your credit on this portion, number one, you correctly answered 7.73. So you had to first get the right answer, and then you had to have enough work to show how you computed those weighted averages. If you did not show enough work to support using weighted averages like you did it in your computer and you had just put the answer down, then you got marked down to partially correct. So you lost credit because you didn't show that method. And there weren't even any additional notes on that. If you didn't do those two things, you got an I. All right, and the last question that was asked of you for this problem is about telling you, so they tell you, high school B has a standard deviation of 7.2. So what proportion, so let me look exactly how's it words this. What's the probability, not what proportion, what's the probability that a teaching year for the randomly selected teacher is within one standard deviation of the mean of, and they reminded you that the mean was 8.2. Justify your answer, of course. So here the first piece that you had to get correct was the fact that the lower bound for the one being one standard deviation below the mean was 1. Right here, 8.2 minus 7.2 is 1. And then the upper bound of 8.2 plus 7.2 is 15.4. So you could either say 1 to 15, since the teaching years were in integers, or 1 to 15.4. All right, so that was component 1 that you had to get correct. Component 2, you then had to sum up these totals of these bins on your histogram of the first 5 bars or bins here for the histogram. And so when you summed those up, you got 189. If you were a little bit off on this, so say you called this 27 or something instead of 28, you lost 0 credit on that because they would see your work of adding all of those up. Again, see, showing your work of adding all of those up and getting that sum really close to 189. So that was part number 2 that you had to get correct to get full credit for this problem, this portion of the problem. The third component was then turning that number into a percentage because it's a probability. So 189 divided by the total of 221 is 85.5%. If you went straight from saying the bounds are 1 to 15 and then you went to 85.5%, you lost credit for showing that process of how you came up with 85.5 and you would have gotten partial credit. And so it specifically states that right here in the third part, you had to definitely look, if the response reports the correct probability without supporting work, then you got marked down to a P. So that's why I've, told you all the time, work to prove how you came up with your values. Now, one very, very, very important thing. If you know that with a normal model, your distribution of percentages are 68 are within 1 standard deviation, 95 are within 2 standard deviations, and 99.7 are within 3 standard deviations, 68, 95, 99.7. And so then you said, hey, it's 68%. You got automatically an I, because this shape is clearly not unimodal and symmetric and approximately normal. It's definitely skewed. So you would have gotten that incorrect all from the get-go, an I. All right, so then let's talk about, once you've gotten your E's, P's, and I's for those 3 pieces, now we want to translate this 2018 test number 5 into a score of 1 to 4. And so if you got 3 E's, then you got a score of 4 points for that. If you had EEP, EPP, then, or EPP, so if you got these 2, then you got a score of a 3 for that. If you got EEI, EPI, or all 3 were partially correct, you got 2 points. That's considered a developing response, which is still strong and still could give you a good score on the exam, depending on how you did on the breast. And a minimal, so at least pulling out 1 point on this, you get an E or PPI. If you did not have any of those, you got a 0 on that free response and did not contribute to your overall score. All right, so I hope that helped you. Do get some components and validation that you must show your work on those things to get that credit. All right.